Hello friends, welcome to EduPanther. Uh, this is our next lecture on differentiation. Topic for this lecture is higher order derivatives. So first we'll see what is mean by higher order derivatives. So as its name suggests, it's higher order. Now what is mean by order of derivative? So here we can say order of derivative means what number of time we are differentiating a function. So suppose if we are differentiating a function two times, so that can be denoted by f double dash x or d square y by dx square. So meaning of d square y by dx square is first take first derivative of your function and then again differentiate it. That means d by dx of dy by dx. So if we are differentiating our function two times, so that derivative will be called as second order derivative. So here first notation for that is f double dash x, or we can use d square y by dx square. In some notebooks they are using this notation also, y2. So your y2 stands for second derivative of your function, second order derivative. Similarly, if we differentiate our function three times, so that means notation is f triple dash of x or d cube y by dx cube. That means differentiating a second order derivative. That means differentiating your function three times. So that will be called as third order derivative. So one more notation for this is y3. So we have seen three notations, either y3 or f triple dash of x or d cube y by dx cube. Similarly, if we differentiate our function four times, so that will be denoted by f4x or d raised to 4y by dx raised to 4. That means differentiating third derivative again. So that is your fourth order derivative. Similarly, if we keep on differentiating our function n times, so that nth derivative will be called as nth order derivative. So that means it is derivative of the n minus 1 order. So this is your nth derivative, and you can use this notation yn for this nth order derivative. So just remember this. If we are differentiating a function two times, then it is second order derivative. If we are differentiating it three times, then it is third order derivative. Similarly, if we are differentiating four times, then fourth order derivative. And in general, if we are differentiating n number of times, then it is nth order derivative. Now we'll see how to find second order derivative of any function. So let's take a question. The question is find second order derivative of the following function. So we have to find second order derivative, that means we have to find d square y by dx square. So our question is y is equals to 2x raised to 5 minus 4x cube minus 2 by x square minus 9. So how will you take second order derivative of this function? So what we have to find d square y by dx square. So our first step will be first differentiate this function one time, and then whatever we are getting after the differentiation again differentiate it one more time. So first differentiating with respect to x. So left hand side is derivative of y, means dy by dx is equals to derivative of right hand side. So now just take derivative of each term. So 2 is constant as it is, derivative of x raised to 5 is 5x raised to 4. Similarly, your derivative of x cube is 3x squared. Derivative here 2 is constant, so keep it outside, and derivative of 1 upon x square is minus 2 upon x cube. 9 is constant, so its derivative is 0. Now simplify this expression. So you'll get 10x raised to 4 minus 12x square plus 4 upon x cube. This is your first derivative, or we can say first order derivative. But what we have to find here? Second order derivative, or d square y by dx square. So again we will differentiate this function with respect to x. So again we are differentiating with respect to x. So that means we have to take derivative of left hand side as well as derivative of right hand side. So derivative of left hand side means d by dx of dy by dx, which is equals to derivative of right hand side. Now this derivative of left hand side, that means d by dx of dy by dx, is our second derivative. So it will be denoted by d square y by dx square, which is equals to, now take derivative of right hand side. So take derivative of each term. Derivative of x raised to 4 is 4x cube, derivative of x square is 2x, and similarly this 4 is constant, keep it outside, and derivative of 1 upon x cube is minus 3 upon x raised to 4. So now we have calculated the second order derivative. We just have to simplify the expression. So after simplification we'll get second derivative as 40x cube minus 24x minus 12 upon x raised to 4. So this is a second order derivative. So this was the normal question. Here function was given in the form y is equals to f of x. That means this is explicit type of function. Now next we'll see how to find second order derivative in case of implicit function. And then if you want to know more about implicit function, you can watch our previous videos on differentiation of implicit function. So again same question, find d square y by dx square. That means we have to find second order derivative. Here question is x is equals to sine theta, y is equals to sine cube theta, and we have to evaluate it at theta is equals to pi by 4. Now here x is written in terms of theta, y is written in terms of theta. So that means theta is your parameter here. So what is our first step? First step will calculate first derivative. That means first we'll calculate dy by dx. Then again we'll differentiate it with respect to x. So start with x. X is sine theta. We'll differentiate it with respect to theta. So derivative of x with respect to theta is dx by d theta, and derivative of sine theta is cos theta. So this is our equation number 1. So we have found dx by d theta. Now we'll calculate dy by d theta. So our y is sine cube theta, again differentiated with respect to theta. So that will give dy by d theta is equals to, now how to take derivative of sine cube theta? Here we have to use composite rule of differentiation. So first take derivative of this 3 and then multiply it with derivative of sine theta. So derivative of 3 means derivative of x cube. So derivative of x cube is 3x square. So that will give us 3 sine square theta into derivative of this sine theta. So simplified, 3 sine square theta, derivative of sine theta is cos theta. So this is our dy by d theta. Suppose this is equation number 2. Next we have to find dy by dx. So dy by dx, so formula for dy by dx is what? In case of parametric function, this is dy by d theta upon dx by d theta. Now from equation number 1 and 2, substitute those two values over there. So we'll get 3 sine square theta cos theta upon cos theta. Now simplified, we can cancel out this cos theta here. So what we are left with, 3 sine square theta. So this is our first derivative, or we can say first order derivative of the function. So say it is equation number 3. Now to find d square y by dx square, we have to differentiate this equation number 3 again with respect to x. Remember here, we have to differentiate with respect to x now, not with respect to theta. So differentiate with respect to x. Note down this step. This is differentiation with respect to x and not with respect to theta. So left hand side will be d by dx of dy by dx is equals to d by dx of 3 sine square theta. So derivative of dy by dx will give us d square y by dx square. So derivative of this function gives d square y by dx square. And now note down this derivative. So here we have to differentiate with respect to theta, but here variable is theta. That means we have to use composite rule. So first this 3 is constant, so keep it as it is. Next we have to take derivative of this square. This power term is there. So first take derivative of square. So derivative of x square is 2x. So it will be 2 sine theta. Then we have differentiated square. Now take derivative of sine theta. Derivative of sine theta is cos theta. Now this extra term is here, this d theta by dx. So we have differentiated this square. Then we have differentiated sine. Then what is left over there? Theta. So we have to take derivative of theta also with respect to x, because here we are differentiating with respect to x. So that will give us d theta by dx. Now how to find the value of d theta by dx? So if we notice equation number 1, so in equation number 1 we have dx by d theta. So from that equation we'll get d theta by dx as 1 upon cos theta. Now substitute that value in the equation. So your d square y by dx square will be, see, this will be 6 sin theta into cos theta, and d theta by dx is 1 upon cos theta. So if we cancel this cos theta, so we'll get d square y by dx square as 6 sin theta. So this is our second order derivative. Now we have to evaluate this derivative at theta is equals to pi by 4. So substitute theta is equals to pi by 4 here. So our derivative will be 6 sin, and in place of theta substitute pi by 4. So 6 into, and sin pi by 4 is 1 by root 2. If we simplify this, we'll get 3 root 2. So this is our second order derivative evaluated at point theta is equals to pi by 4. So this was finding second order derivative when implicit function is given. Now next, see, in this question, y is given as e raised to m into tan inverse of x. Now instead of finding second order derivative, we have to prove something. So we have to prove that 1 plus x square into d square y by dx square plus 2x minus m into dy by dx is equals to 0. Now for such type of functions, what we can do, see how many derivative terms are involved here. First we can see this dy by dx is there, similarly d square y by dx square is there. So dy by dx means what? Differentiate your function one time, d square y by dx square means it is second order derivative. So find all those values and substitute in this left hand side of the equation, we should get right hand side. Or what else we can do, we can directly start differentiating and try to simplify that expression so that it gives us directly this equation. So let's start solving this question. So question is y is equals to e raised to m into tan inverse x. So our first step will be, we'll differentiate with respect to x. So it will be derivative of e raised to m into tan inverse of x. Now pause your video here for some time and try to calculate the derivative of this function e raised to m into tan inverse of x, and comment your answer. Now we'll see whether your answer is correct or not. So here first we can see we have function e, then in its power we have m into tan inverse of x. So we have to use composite rule. So first we'll take derivative of e. So derivative of e raised to x is e raised to x. So it will be same, and we have to multiply it with derivative of this power. So means derivative of m into tan inverse of x. Now further we'll take derivative. So here first term is as it is. Now derivative of m into tan inverse x. So m is constant, keep it outside, and derivative of tan inverse x is 1 upon 1 plus x square. So after simplification we'll get m times e raised to m into tan inverse x upon 1 plus x square. This is our first order derivative. So this part we have calculated. Now we want second order derivative also. So now there are two steps here. First what we can do, we can directly differentiate this function and then we'll get the second order derivative. Substitute all the values in this left hand side of the equation, we'll get the right hand side. Or else we can simplify our process. So how to simplify this? See, if we take derivative of this function, so either we have to use u into v or u over v. So to get rid of that u over v formula, we can shift this 1 plus x square on the left hand side. So after shifting we'll get 1 plus x square into dy by dx is equals to m into e raised to m tan inverse of x. So this is simplify our process of differentiation. So now we have first order derivative, again we have to differentiate it with respect to x. So after differentiation, so derivative of left hand side is equals to derivative of right hand side. Now we'll see how to find derivative of left hand side. In left hand side we have product of two functions. For your first function is 1 plus x square and second function is dy by dx. So take first function as u, second function as v, and apply product rule, means derivative of u into v. So derivative of u into v is u into derivative of v. So see, u means your first term into derivative of v means derivative of dy by dx plus v. V means dy by dx into derivative of u. So derivative of 1 plus x square is equals to, now take how to take derivative of right hand side. This we have differentiated here only. So that differentiation will give us m into e raised to m tan inverse x into m into 1 upon 1 plus x square. Now simplify this expression. So 1 plus x square as it is. Now derivative of dy by dx will be second order derivative, d square y by dx square, plus dy by dx as it is, and derivative of 1 plus x square is 2x. This is equals to, now simplify this expression, will get m square e raised to m tan inverse x upon 1 plus x square. Now at this point, if you note down, see in our proof what do we want, 1 plus x square into d square y by dx square. So that term we have already got here. We just need 2x minus m into dy by dx. Out of that we have got 2x times dy by dx. So now what is remaining here? So we have to arrange m times dy by dx. So we'll simplify this right hand side to get m times dy by dx. So left hand side is as it is. Now note down this equation number 1 where we have found the derivative of first order derivative. Okay, so take 1m outside and remaining terms inside this bracket. So we'll get m into m e raised to m tan inverse x upon 1 plus x square. So compare this with equation number 1. So as we can see, this bracket term is same as a dy by dx. So your left hand side is as it is, m into, this is dy by dx. This is using equation number 1. Next, shift all the terms on one side. Now why we are shifting? Because in our proof your right hand side is 0, so shift every term on the left hand side. So this is equals to 0. So now what we can do, this first term is as it is. From these two terms we can take dy by dx common. So this will give us 2x. This will give us whatever we have to prove. This is equals to 0. See, here we have not taken the left hand side. We have directly differentiated, and by simplification we directly got whatever we had to prove. This is one of the method. Suppose if you don't know how to do this, then what we can do? Find first derivative, second derivative, substitute everything in the left hand side. We will get the right hand side. Now we'll see one more question on this proving part. So question is, if x is a sin t minus b cos t, y is a cos t plus b sin t, then we have to prove that its second derivative is equals to minus x square plus y square divided by y cube. So as we can notice here, x is written in terms of t, similarly y is also written in terms of t. So what kind of functions are these? Now comment your answer. Yes, so these are parametric functions because they are represented using some another variable. So we'll take the derivative. Now we have to prove something related to second order derivative. That means first find first order derivative, then second order derivative. So we'll start with differentiation of x. Okay, so just note down this step. Instead of differentiating with respect to x, we have to differentiate with respect to t because your parameter is t. So we'll get dx by dt as a derivative of sin t is cos t minus b times, now derivative of cos t is minus of sin t, so that will make it plus b sin t. So this is our equation number 1. Now take y is a cos t plus b sin t. Again, instead of differentiating with respect to x, we have to differentiate with respect to t. So dy by dt is a times derivative of cos t is minus sin t plus b times derivative of sin t is cos t. This is simple. This is your second equation. So we have got dx by dt, dy by dt. First we need to find dy by dx. So in case of parametric function, formula for dy by dx is dy by dt upon dx by dt. And from equation number 1 and 2, we can substitute the value of numerator as well as denominator. So if we substitute the value, what we will get? Minus a sin t plus b cos t upon a cos t plus b sin t. Okay, now at this step, just try to simplify this expression, whatever we have got here. As you can notice here, the denominator is a cos t plus b sin t, and if we notice our value of y, so your denominator is same as y, a cos t plus b sin t. That means in place of denominator we can write y, but numerator is minus a sin t plus b cos t. That is almost same as this x, but it is differing by this minus sign. So to get that minus sign over there, what we can do, we can take minus sign common from the numerator. So take minus sign common from the numerator. So our numerator is x, denominator is y. So dy by dx will be minus x over y. Suppose this is the equation number 3. So now we have got the first order derivative. We have to find second order derivative. So what will be our next step? Yes, we'll differentiate with respect to x again. So again differentiating with respect to x. So derivative of left hand side will give us, so derivative of this term will give us d square y by dx square, which is second order derivative, and derivative of right hand side. So derivative of right hand side, it is what, division of two functions, so we have to use derivative of u by v rule. So that will give us this part. Okay, now simplify this right hand side tip. So y into derivative of minus x is minus 1, then this minus minus will become plus, derivative of y is dy by dx. Now at this step what we can do, see, from equation number 3 we have got the value of dy by dx, that we can substitute here. So substitute that value and see what we will get. So it's minus y plus x into your dy by dx is minus x over y upon y square. Now just simplify this expression, normal cross multiplication. So that will give us minus y square minus x square upon y square. Just take minus sign common from the numerator and simplify this. So we'll get a final answer. This is what we had to prove. So this is proving something related to second order derivative in case of an implicit function. So now in all these examples we have only calculated second order derivative, but in the introduction we saw we can find third order derivative, fourth order derivative, similarly we can find nth order derivative. So now we'll see one example where we have to find nth order derivative of a function. So question is, find nth order derivative of this function ax plus b raised to m. So first take your function as ax plus b raised to m. Now here value of m is not given and value of n is also not given. So how many times you have to derivate, that is not fixed here. So in such cases what we should do, the procedure is find your first order derivative, second order derivative, differentiate a function 3 to 4 times, so that try to find a pattern in the answer of derivative and write the general formula for that pattern. We'll try to do that for this function. So first step will be differentiated one time. So differentiating with respect to x, so that will give us dy by dx is equals to, now derivative of ax plus b raised to m will be simple, m times ax plus b raised to m minus 1 into derivative of ax will give us a. So this is first order derivative. Next step, find second order derivative. So again differentiate it with respect to x. So derivative of dy by dx will give us d square y by dx square, and again differentiate this, so we'll get m times m minus 1. Now how we are getting this a square? This a was already there, so after differentiating this part one more a will come, so it will make it a square into this ax plus b raised to m minus 2. Again differentiate it one more time, so that will give us third order derivative, which is d cube y by dx cube. Okay, so this is our third order derivative. Now in same order, like we can keep on finding fourth order, fifth order derivative, sixth order derivative. So and so on, we'll find the nth order derivative. Now see, your nth order derivative will be, now how I have written this expression for nth order derivative, so that we'll see here. See, when it was first order derivative, your power we had m here, power of a was 1, and this ax plus b has the power as m minus 1. Okay, so power of m is here, then power of a is 1, then power of this ax plus b is m minus 1. Now in second order derivative we got m into m minus 1, power of a became 2, and this power of x plus b became m minus 2. And similarly for third order derivative. Now as we can notice here, see in the second order derivative, power of like, see, it was second order derivative, that means this 2 was there, so it is same as power of a, that means we can notice here. Similarly in third order derivative, power of a is same as, power of a is same as the number of derivatives. So that means so in our nth order derivative, see here, power of a, This power of a is same as number of derivatives. So here in nth derivative, power of a will be n times. Now we'll see power of ax plus b. So in first order derivative it was m minus 1. In second order derivative m minus 2. Similarly in third order derivative m minus 3. So see here this 1, 2, 3. So this is giving us number of derivatives. Now, similarly in case of nth order derivative it should be n because this n is there. So it is m minus n. So we got this power also. Now we'll see how we got this m into m minus 1. See. So in first order derivative it was m. In second order derivative it is m into m minus 1. That means 1 less than, see, this number. 1 less than the number of derivatives. Similarly in case of third order derivative it was still m minus 2. That means 1 less than 3 minus 1. So 1 less than the number of derivatives. Similarly here we have nth order derivative. So this m terms will be 1 less than. So 1 less means what? N minus 1. So it will be m minus 1, m minus 2, m minus n minus 1. So this is the general expression for nth order derivative for this function ax plus b raised to m. Now we will try to simplify this expression further. So this was our derivative. Now if we know the formula for n factorial. So what is n factorial? It is n into n minus 1, n minus 2. Similarly till 3 to 1. So this is your n factorial. So we'll try to write this these terms as m factorial. So for that just note down this step. First your m wala terms are all there. M minus 1, m minus 2, m minus into this a raised to n into ax plus b raised to m. Now we have to convert this term m minus 1, all these terms. We have to convert all these terms into m factorial. Now what all terms are remaining here? So we have product of numbers till m minus n minus 1. So what will be our next step? Sorry, what will be our next term? Next term should be m minus n. Then after that it should be m minus n plus 1 and so on till 3 to 1. So that means these many terms are remaining. So we have to multiply those many terms here. So we are multiplying those many terms here m minus n plus 1 till 1, and since we are multiplying in the numerator, so to balance it we have to multiply in the denominator also. So now notice your numerator. So this product m minus 1 till 3 to 1, that is the definition of m factorial. So your numerator will become m factorial. In the denominator, notice here we have product till 1 and it is starting from m minus 1. That means your denominator is same as m minus n factorial into this a raised to n is there and then ax plus b raised to m. Now this is nth order derivative of your function ax plus b raised to m. Now for different values of m and for different values of n, we'll see how your formula looks. See, so if m is positive, in all cases we'll take m as positive, and if m is greater than n. If m is greater than n, that means what? If power is greater than m, then this will be your derivative that we have calculated. Okay, but if m is equals to n, then in that case this formula becomes n factorial upon a raised to n into x plus b raised to m. Now what will happen if m is less than n? M is less than n, that means just take an example. Y is equals to, say I'll take a simple function 2x plus 3 raised to 3. Okay, this is your m. Suppose we have to find nth order derivative where n is, say, we'll take something more than 3. So if it is 4, say take 5. So if n is equal to 5, because n is equals to 5. So in that case, fifth order derivative. So d phi ty raised to 5. So what will be fifth order derivative of this function? Now try to find the differentiate this function 5 times and see what we are getting. Yes, so we are getting 0. So that means if m is strictly greater than n, then in that case nth derivative will be 0. So this is your final answer, whatever is written in the bracket. So this was the nth order differentiation. So this is all what we have in higher order differentiation. So if you have any doubt in this lecture or in previous lectures, please do let us know. Thank you.